All right? So number 8 has like a set of parentheses and then squared. So before we talk about that one, what does it mean if I square something? So like what does 5 squared actually mean? 5 times 5. It means you take whatever you're squaring and you write it twice, right? 5 squared is 5 times 5. So if you look at number 8, you see that, right? All right, so quickly, let's head to our toolkit to page 3. We're going to do one similar to number 8, and then you're going to go back and you're going to try number 8. So remember what we said about 5 squared. 5 squared is 5 times 5. So x plus 8 squared is what? X plus 8 times x plus 8. Almost always, I have a student do this. That's not the answer, okay? You do not distribute in. X plus 8 squared means x plus 8 times x plus 8, right? When you square something, you write it out twice. And now, this is what we did yesterday. We take that first set of parentheses, we separate it, and we multiply them by the second set of parentheses. So I am making sure that the x goes to the x and the 8, and the 8 goes to the x and the 8. So I'm writing it out like this. This is what we did yesterday with the binomial times the binomial. Don't forget that when you have something that doesn't have an exponent, you got to put the 1 in. So this is keep the base, add the exponents. X times 8 is 8x. 8 times x is 8x. 8 times 8 is 64. And then when we combine those like terms, 8x plus 8x, we get there are 25 kids in this class. Without fail, 3 of you, at least, are going to do this on the test. Even though I'm saying it out loud right now. And even though you can check it using y1 and y2 in your calculator. At least 3 of you are doing this, okay? Remember what it means to square something. It means I am writing it out twice. So write it out twice and then distribute. X plus 8 squared is not 8 squared plus 64. It is x squared plus 16x plus 64, all right? So head to page 8, or sorry, page 9 or 10. I forget which page it was. Page 10, and try number 8. Okay, remember, x plus 6 squared is not distributing in the 6. Okay, x plus 6 squared means x plus 6, x plus 6. If you get x squared plus 36, you did something terribly wrong. It is not x squared plus 36. When you square something, you're writing it twice. X plus 6 squared is x plus 6 times x plus 6. So I'm going to take the x from the first set of parentheses and distribute it to the x plus 6 in the second set of parentheses. And I'm going to take the plus 6 in the first set of parentheses and distribute it to the x plus 6 in the second set of parentheses. I like to add 1s to all of the x's so I don't forget about the degree of 1. So this would be keep the base, add the exponents. 6 times x is 6x. 6 times x is 6x. 6 times 6 is 36. And then I would combine those like terms. X squared plus 12x plus 36 is what I get here. Don't forget you have a tool to check your answers. You've got a quiz on Thursday. You can check all of your answers except for naming them. Okay, the names you can't check on your calculator, but besides that, 100% of the quiz can be checked using Y1 and Y2. If you type this in Y1 and this in Y2, they won't match. All right, you got to do the original question and this x squared plus 12x plus 36. Those will match. All right, so any questions on that? All right, the last concept from this section is called finding the area of the shaded region, okay? Which seems like it wouldn't be a topic that goes with this, but you'll see when we go to find the area of something, it ends up being part of what we've been doing in class, okay? So we are in our toolkit still, and we are on page 4, and you'll start to see these like shapes, right? Think of this as like a picture frame. I'm looking to find the area of the frame without the middle, okay? So I want to get rid of the middle. So to find the area of the shaded region, the formula is area of the big shape minus area of the small shape. It's always that formula. Area of the big shape minus area of the small shape. Now, both of those shapes are rectangles. Does anybody know how to find the area of a rectangle? Base times height, length times width, right? So like area of a rectangle is length times width. So that formula is the formula we're going to use because all of these shapes we're going to do in this unit are going to be rectangles. Some of you, if you do an extension, you might be working with like circles and triangles. But for the actual unit that you are being assessed on, we're going to work with rectangles only. So you just have to remember that area is length times width. So the formula is area of the big minus area of the small. So if I wanted to find the area of the big rectangle, I'm going to do the length times the width of the big shape. So 12 times 10, or 10 times 12, the order doesn't matter. So the area of the big shape is 12 times 10, or 120. And technically the units are meters squared, but it doesn't really matter if you put the units here. All right? So area of the big, length times width. All right? Area of the small. Now I'm looking at the smaller rectangle that's inside. 7 times 2, or 2 times 7, the order doesn't matter. 14 meters squared. So the formula for area of the shaded region, so this is all 120, and then I want to subtract the 14, and I'm only going to be left with the stuff that surrounds it. So that's why I'm taking out the small. So I'm going to do area of big minus area of small. And now that I know what both of those numbers are, I can find the shaded region. So I'm just going to filter in their numbers. The area of the big was 120 meters squared. Minus the area of the small was 14 meters squared. So the area of the shaded region is 106. If you only want the outside stuff, you have to deduct the small shape to get rid of it. That's why it's subtraction. You might be thinking to yourself, what does this have anything to do with what we're doing right now? But if you look at the next examples, the side blanks now are polynomials, okay? So we're going to do multiplication, because the formula is length times width of polynomials, which is what we did in class yesterday. So it does apply. And then it's subtraction, right? Because it's a minus. So we're also going to add and subtract polynomials too, which is what we did last week. So these problems really put everything that we've done since last week together in one problem. All right, so what we have to remember is the area of the shaded region is big minus small. So let's first work on the area of the big shape. The big shape is this red one. So its side lengths are these two things. All right, so when I multiply them, length times width, I'm going to put them in parentheses. Because they're polynomials, it will be more organized with the parentheses. Length times width, the order doesn't matter. So you could put the x plus 15 first or second, it doesn't matter, right? But it's length times width, so I'm just putting them next to each other. If you want to put a dot in the middle to show times, you can, it doesn't matter, right? And this is a binomial times a binomial, so remember what we did yesterday. We take the 3x from the first set of parentheses, and we multiply it by the x plus 15 in the second, and we take the plus 2 in the first set of parentheses, and we multiply it by the x plus 15 in the second. I'm making sure that I distribute everything from the first to everything from the second. I'm going to add in ones to all of my x's that don't have exponents. And now I'm going to do this multiplication. Multiply the numbers in front, keep the base, add the exponents. Multiply the numbers in front, keep the base. There aren't any exponents to add there, so I'll just keep that as a 45x. 2 times x and 2 times 15. My last step for this one would be to combine those like terms. So the area of the big is 3x squared plus 47x plus 30. All right? So I'm finding the area of the big. Now over here, I'm going to do the area of the small. Here's the small one. Length times width. It doesn't matter what order you put it in. Essentially, I'm just distributing the 2x, right? There's only one term here. So I'm doing x times 2x and 1 times 2x. Don't forget that there's ones on these though, right? So x times 2x is 2x. Add the exponents squared. And 1 times 2x is 2x. Everybody okay with what I did there? First term times first term times second term. Any questions so far? All right, so finally, putting it all together, the area of the shaded region equals, now I'm going to put them in parentheses, and you should too. Area of big minus area of small. And I'm going to put them each in their own set of parentheses. So I'm going to plug in what I know. I know that the area of the big is 3x squared plus 47x plus 30 minus, and then in its own set of parentheses, 2x squared plus 2x. Without the parentheses, you might forget that you're subtracting both of those second terms, and you might just subtract the first one. With the parentheses, you'll distribute the minus. So just the parentheses is a really good habit to get into here. So remember, if we have parentheses, then we need to put ones in front of them and distribute those. So I get 1 times 3x squared, 1 times 47x 1 times 30. And this is like a negative 1. Negative 1 times 2x squared. Negative 1 times positive 2 is negative 2x. If anything, if you're going to make a mistake anywhere, you're going to have that last term be a plus 2x instead of a minus. But I'm subtracting the entire small shape. So this becomes a minus and this becomes a minus. I have to subtract both parts of it. And then from here, I'm going to combine like terms. So I've got 3x squared and negative 2x squared. And I've got 47x and negative 2x. So the area of the shaded region ends up being 3 minus 2 is 1, so x squared. 47 minus 2 is positive 45, and then I'll keep the x, and then plus 30. So the area of the shaded region is this new formula. All right, so we're going to try another one just for extra practice with this. I think there's one more in your toolkit. All right, so to find the area of the shaded region, we're going to do the area of the big minus the area of the small. So the length of the big and the width of the big, you can obviously switch that. Okay, you don't have to write it in that order. So I'm doing the first x times the x minus 1 and the plus 5 times the x minus 1. I'm putting ones here, so I remember to add them. X times x is x squared. It's not x. It's not 2x. You keep the base and you add the exponents. X times negative 1 is negative 1x. 5 times x is 5x. And 5 times negative 1 is negative 5. I just have to combine my like terms. Negative 1 plus 5 is positive 4. So this is the area of my big. I went kind of fast. We did that yesterday, so hopefully you're okay with that. Area of the small. So I'm looking at the side lengths of the small. It looks like I have a plus 1 and a minus 4. Doesn't matter which one you write first. The first x times the x minus 4 and the plus 1 times the x minus 4. You just have to make sure you're distributing to everything. Don't forget to put the ones, because I'm going to keep the x and add the exponents. X times x is x squared. X times negative 4 is negative 4x. 1 times x is 1x, and 1 times negative 4 is negative 4. I just have to combine my like terms. Negative 4 plus 1 is negative 3x. This is the area of the small. So the final step would be to find the area of the shaded region. You're going to do the area of the big in parentheses minus the area of the small in parentheses. So the first set of parentheses would be x squared plus 4x minus 5, because that's what we got in red for the big shape. And the second set of parentheses will be x squared minus 3x minus 4, because that's what we got in blue for the small shape. And I'm going to put ones here. And I'm going to distribute the 1. 1 times x squared, 1 times 4x, 1 times negative 5. Negative 1 times x squared, negative 1 times negative 3 makes positive 3x. Negative 1 times negative 4 makes positive 4. And then I'm going to combine like terms. What happens to the x squareds? They 0. I'm not going to write the x squared terms at all. X squared minus x squared is 0. So I've got 4 plus 3, so 7x and negative 5 and positive 4 makes negative 1. So the area of the shaded region is 7x minus 1. When you come in tomorrow, you're going to practice that. And then in addition to that, you'll just do more practice of what we did in the beginning of the class because your quiz is Thursday. So tomorrow is your quiz review day and your actual quiz is Thursday. At this point, you've got your Math Excel. You can finish the whole thing. Do Thursday night. Your quiz is on Thursday.